In this video we're going to look at an example of the method of proof by contradiction. We start with the proposition: the product of a rational number and an irrational number is always irrational. To prove this, we will prove that if we assume the opposite, i.e. that the product of a rational and irrational number is rational, then this leads to a logical contradiction. So let's start our proof. Suppose we have number A, which is the product of two numbers B and C, where we assume B is rational and C is irrational. We're going to assume that A is a rational number, so we can write it as D over E, where D and E are both integers. This means that we can write D over E equals B multiplied by C. Now we've assumed that B is also rational, so we can write B equals F over G, where F and G are both integers. Now we could set D over E equal to F over G multiplied by C, and we can rewrite that as C is equal to D multiplied by G divided by E multiplied by F. Now DG and EF are both themselves integers, and therefore it follows logically that C must be a rational number. But this is a contradiction, since we started with the assumption that C was an irrational number. Therefore, we've proved by contradiction that if we multiply a rational and an irrational number together, then the result must always be an irrational number.